All right, so this one's going to be testing for independence. So this is the last type of hypothesis test we're going to be using for this semester. And this one's going to be testing a two-way table or a constituency table. So what we're going to be doing is we're going to be testing if a row variable and a column variable are independent or dependent of each other. So what that means is we're going to see if does one variable affect the other one or not, essentially. Okay. The good news is, just like a goodness fit test, this also has a template to go through it when it comes to it. Okay. So for our null hypothesis is always going to be the row and column variables are always independent of each other, meaning they do not affect one another. The alternative hypothesis is always going to be they are dependent of each other, or they do affect one another. Okay. Again, it's going to be always this case, which we just going to figure out what our row and column variable is and write them in essentially when it comes to it. Okay. Our test set is also a chi-squared value, and again, it's always a right-tail test when it comes to a test for independence. Okay. Just like a goodness of fit, we still have the exact same test stat equation. However, to find degrees of freedom is very different. To find the degrees of freedom, it's the number of rows we have minus 1 times the number of columns we have minus 1. So we got to figure out how many rows and columns we have, subtract 1, and then multiply that result together. Okay. But again, just like we did for the last section, we won't have to calculate the actual chi-squared value, so don't worry about that. We can use a website for it as well. But that's what we have to do to find our new margin of error. It's a little different when it comes to it as well. Okay. To find our critical value, we do the same thing. Find our chi-squared value, use the degrees of freedom alpha to find that value. Again, it's always a right-tail test, so you're fine based off that. And then finally, to write your conclusion, again, we're going to write which one is actually true. So based on our experiment, is our null hypothesis true or our alternative hypothesis is true? Okay. So let's see an example so you can see how that's going to work out here. Okay. So example 1 says, data shows the results of effectiveness of influenza on common colds. Use a 0.05 centimeters level test to claim that getting an infection is independent of the treatment group. Okay. Now it tells us exactly what we want, right? So getting an infection and the treatment group are our row and column variables. Okay. And then notice we have here, we have placebo, 20% extract, 60% extract, infected, non-infected, right? So this is the treatment group, this is the infection group, right, when it comes to it. So our null hypothesis is the treatment group, so literally just copy this down. The treatment group, treatment groups are, so the treatment groups are independent of you getting an infection, and the other one is the exact opposite. Are dependent of you getting an infection. Okay, and that's it. So you could literally copy exactly that, and you'd be perfectly fine when it comes to it. So again, we have a row and a column variable respectively. Okay, and again, the key word is make sure they're independent for our null and dependent for our alternative. So just make sure you just delete that. I guess I don't know what I did there when it came to it. Okay, so yeah, all this fun stuff we can skip because we're going to use our website to do it, but this is what we have to do the old-fashioned way, and see we get the exact same thing if we would do it as well. Okay, so let me show you how we're going to do it in our website. So if you click on our website, you can have this, and you're just going to put the numbers respectively where they're supposed to be in here. So I'll just put it on away screen so you can make it easier. So it'll be 81, 48, 42, 15, 4, and 10, and leave everything else blank when it comes to it. Okay? So you should put it exactly as you see it. Press calculate, and there you go. There is our chi-squared value, which is identically what we would do if we do the old-fashioned way itself. Okay? So that is our test stat. To find our degrees of freedom, well, how many rows we have? 2 rows. So that's why it's 2 minus 1. How many columns? 1, 2, 3. So 3 minus 1. So this gives you 2 times 1, which is just 2. So again, just go to our critical values. So going to our chi-square distribution and just finding that route. So 0.05, degrees of freedom of 2, and that's it. 5.991 is our critical value. And again, remember, it's a right tail test. So since we want everything on the right tail, Everything greater than this means we reject. So since this is not in our critical region, we will not reject the null hypothesis. So that means our independent of you getting an infection when it comes to it. Okay? So that's exactly when it comes to a test for independence itself. So, sorry, in a nutshell, we're going to write our null alternative hypothesis, use our website to get our test stat, and then analyze it using our critical value, and there we go when it comes to it. Okay? So let's try some on our own. So let's actually do number 2 first, because I want to talk about a little bit number 1 as well. So let's just skip and go straight to question 2, example 2 itself. So assume that the survey was designed so that a male interviewers were instructed to obtain 800 responses from male subjects. A female interviewers were instructed to obtain 400 responses from the male subjects. Use a 0.05 significance level to test a claim that the proportions of agree/disagree responses are the same for the subjects by men and women. Okay, let's find our null and alternative hypothesis. So null hypothesis is the proportion of responses between men and women are independent of if they agreed or not, or agreed/not agreed. So alternative hypothesis is exactly the opposite. So all you really have to do is change one word, and that one word is independent. Okay, there we go. So now we go on to our test stat. So our test stat is a chi-squared value, so I'll just put that for short there. And again, in this case, we're just going to plug it in. So go back to our website. We're just going to plug in all this respectively, and I don't think there's no clear button, so it's fine. Just delete these values then. And let's plug in our values. So 560, 308. 240, 92. I think that's it. Okay. Calculate, and there is our test stat. Voila. Okay. So now we just need our critical value. So to get this, we need degrees of freedom. So to do that, we're going to do how many rows we have, which is 2, minus 1, times how many columns we have, which is also 2, minus 1. So this just ends up being 1 times 1 was just 1, and an alpha of 0.05. So let's go to our portion here. 0.05, degrees of freedom, 1. So 3.841. Here's our critical value. All right, so remember, this is always a right tail test. So when it comes to our conclusion, it has to be greater than this values, which is definitely true. So that means we reject the null hypothesis. We reject H naught. So our conclusion is they are dependent on one another. So depending on, if a man or a woman asks you the question, it changes their answer when it comes to it. Okay? And that's a test for independence there. So now let's go on to the other question here. So this is the interesting one. So let's see. So test the claim whether Gilbert was on duty for a shift is independent of whether a patient died during the shift, where the significance level is 0.05. And in fact, we're going to do even better than that. We do 1%. Super, super small chance. Okay. So believe it or not, this is actually a real life scenario that happened a couple of years ago when it comes to it. Miss Gilbert was actually a nurse who was on trial for killing her patients while she was on duty. Okay, so this is either going to help her or harm her based on the information. But this is a cool little thing if you guys are wondering when this stuff is actually done, and this is a huge actual case, right? So it could be someone's life happening in the balance of just pure mathematics when it comes to it. Okay, so let's see, let's see mathematically, can we see, can she be guilty or not guilty, right? Depending on what we have here. So first off, let's write our null hypothesis. So H1, or sorry, H naught. So this is exactly this. So Gilbert was on duty for a shift is independent whether the patient died during the shift. Or we'll just say Miss Gilbert. She was a lady. Alternative, well, it's exactly the opposite. Right? So H1 is they are dependent on each other. All right, so let's go to our test stat. So again, it's a chi-squared value. And let's see what we get. So now we'll just plug in our numbers here. Okay. Yep. Right, calculate. And we get a chi-squared value of 86. Ooh, pretty big, right? So let's see, that's that. All right, so next thing we want to find is our critical value to see if we reject or not reject. So degrees of freedom here is going to be, again, it's 2 by 2, so I'll just skip that word and just say 1. And again, with an alpha of 0.01. Where's my alpha? Sorry, it's right here, right? 0.01. So let's find our critical value. 0.01 with 1 degree, 6.635. So if you notice, we definitely reject, right? There's way big when it comes to it. It's way in our region, and if you look at it, even if you use the smallest alpha, which is 0.005, that is still drastically bigger. So it's definitely in the region when it comes to it. And fun little fact, if you went by 0.00001, even smaller, this will still be in the region because our test stat is such a high number itself. Okay, so therefore, when it comes to our conclusion, there is a big effect, right? While Miss Gilbert was on duty, is very independent on whether the patient died during her shift. So obviously this wasn't, the aha moment in the case, but this was actually used in the case to signify, there's more evidence to show that she actually killed her patients when it came to it. And again, to give you the back information, that she actually pleaded guilty to doing this. So she was actually in prison, and I believe a student of mine a year ago said she was close to getting out. So yeah, she might be getting out from parole or something like that. But get a little fun fact when it comes to, if you guys are wondering where this stuff is come, can I get anything bigger than a murder trial, right? So stats is everywhere, believe it or not, when it comes to it. Okay. So that's pretty much finishes up this section. Hopefully it's not too difficult. It's again, we can use our website to find our test stat, which again, all you have to do is break it through it when it comes to it, fill in the gaps, and then fight your conclusion based off that information.